Sorry. All right, recording now. All right, so fork this over, and then I'm going to clone it. So copy that. Again, you guys have done this probably 40, 50 times by now, so hopefully you guys are tired of this process, but we get clone, and I added it to my challenges folder, so I want to go to SQL basics. All right, there we are, and I'm going to do code period, so I'll bring up my coding window here. So I actually don't want that here. All right, so let's actually give this a read. So we have SQL basics, and first thing I want to do is create a database. So I'm going to go to my terminal here, and yeah, let's actually get some info here. So Daniel, since you were last to talk here, I'm going to actually ping you. Daniel, can you tell me how I can create a database using my terminal?
Yeah, so you could just type in create DB and then the name of the database.
Absolutely. All right, so I'm going to create DB. Again, this is via Postgres. So create DB, and I'm going to give my database a name. So I believe I actually have a school database. I'm going to actually call this school new. That'll be my database name. I hit enter. And again, I got no errors here, so that's a good sign. Again, it'd be nice to have some feedback saying, hey, you did a good job, but I guess the terminal isn't that positive. So my database should have gotten created. Again, I have this Postgres plugin, I guess, for VS Code. So here I do have my school new created. So that looks, again, it's empty. There's no tables in it, but that database did get created. So that seemed to work correctly. Thanks, Daniel. All right, what's our next step? So we did create database. Database name goes here. Then we want to create a schema. So if you want to actually, we talked about types. So again, you can have integers, decimals, varchar, or again, just variable characters. This kind of saves database space because they don't, the data field is as long as the value. They don't pad it with extra strings in Postgres. We can also have characters, text for, I guess, longer strings, dates and timestamps. All right, so we want to create schema here. So we actually have the schema file kind of written for us. We have a table here. So let's look at some of the syntax here. So we have drop table if exists. So this will basically prevent us from keep creating a duplicate table if we run this multiple times. The drop table will actually drop the existing table and all the data in it. So you're going to lose your data and then create a new table from it. So one thing that I always recommend is to have a cascade keyword here. So you guys might have seen this before, or maybe it's unfamiliar. This will actually let you drop the table even if something is referencing your particular table, and we'll talk about references shortly. But basically, if someone is like referencing your ID with a foreign key, you won't be able to drop this table because that table needs that record. But cascade will actually allow you to drop this table and remove that record from any referencing table. So again, you don't have to use this, and again, you may not want to. Like if you have another table and you want to just drop one table, you might not want to drop this table if something else depends on it. But that's what cascade does there. So I'll just add that in there. Unfortunately, they don't syntax highlight it in VS Code. I'm not sure why. All these are in blue, but this one seems to be not part of the party. All right, so we have that. Let's actually just run this to create a students table. So if you look at our students table, we have an ID field, and this is our primary key. We use the serial keyword to kind of auto-generate our IDs for us. So we're not going to specify, hey, this record is ID 1, this record is ID 2. That's automatically done via the serial parameter here, or the serial type. So it's just going to be auto-incrementing, which generally what we want for our IDs. Then we have some simple fields here. We have first name, last name, birth date, which is a date field, and then we have an address ID. So we're going to have an address table at some point. So this is probably going to reference that. So let's actually just try to create this quickly. So let's ask someone out there. Who's on my screen here? Jennifer Clark. Could I ask you, how do I get my schema? How can I get this into my database or run this on my database? I think you're muted. There you go.
Sorry about that. Go to the CLA and then type in PSQL and then I guess school new.
Okay. And then what, do I hit enter?
Enter, yeah, sorry.
Okay. And now what do I do here?
To run your schema file, you mean, or?
Yeah, so yeah, I have
Are
this
we-
here. Do I just copy and paste it? Is there anything else I got to do special?
Oh, if we want to create the table?
Yeah, I just run this SQL command.
Yeah, I would just copy and paste it unless you're actually running or calling the whole file, but I would just copy and paste it if we're just doing this one right here.
Gotcha. Yep, copy and paste works. So now that we're in Postgres, we have this command line. We could type SQL here. And so I just copy and paste, and I think I just enter. All right, so I got some feedback, which the terminal usually does give me, but Postgres is a little more friendly. So I got students does not exist, so it did not have to drop that table. So the drop table that actually didn't do anything in this case, and then I created a table. So they actually ran this again. Now I don't get that feedback. Drop table actually did something, so I don't get that notice. But I could run this multiple times, and this table will just be deleted and recreated each time. Yep. All right. Thanks, Jennifer. So another way we can do this, just to give you an option. So I actually personally don't like writing in the terminal if I can avoid it. So I usually like editing my stuff in VS Code. Again, I can just write commands here if I want to select something. But you could also kind of feed in a file into your database. So to do that, I'm just going to exit out of here, clear my screen. So another way, again, either way is kind of user preference, but you can write pSQL, again, your database name. In this case, it's school new. And you use this character, or use less than a character, and then your schema file. So in this case, I have create schema. All right, so again, this is kind of just feeding this file into your database, and it'll run everything in there. So it kind of saves you from having to do the copy and paste, and you can kind of just edit in your create schema and then kind of feed it in. So if I do this, it should do the same thing. So here, I got the drop table and create table. And if I actually look in my database here, I should have that table hopefully here. I need to refresh. All right, not sure why that table doesn't exist here. All right, but if I actually want to check, I can check on the terminal. So I go to school new, and then \D. All right, so my student table does exist. Again, I'm not sure why this plugin does not show it. So maybe I shouldn't be using this plugin.
Can I ask a question?
Yep.
So the way you called the file onto your table is a little different than the way they're doing. They're using \I, and then the file name, is there a difference?
That's actually a good question. Let's actually look at the README. So on this page?
No, it was just what the guys were using yesterday.
Oh, actually, I'm not sure. We could quickly Google that.
\I lists all the database. \D describes a particular table.
So that the operator is just a redirect. It's a normal bash operator. It just says redirect the output. So you're essentially, it's almost as though you had typed in everything in the file into the interpreter. The /I, I think, is just telling Postgres explicitly that you're using a file.
Gotcha. Thanks, Chad.
I've also been using pgadmin to be able to display the data within my database, and it's been working really well.
pgadmin, like a third-party app that kind of shows you your database.
Exactly.
Yep. Yeah. So yeah, again, there's many Postgres applications out there that can give you a visual. And again, I like having visuals, so I actually have one installed. Also, outside of VS Code, it's just a server that you can run that kind of shows you all the data. You can kind of see what's in your tables. So yeah, you guys can kind of hunt around for the applications that makes it easier to view your database.
Yeah, and we at the end of the day, we can go through some of those applications. I use one called Post2Co.
All right, so where were we? SQL basics. All right, so we ran our schema file with our existing table, but we probably want to add some more data here. So we have these tables here. So let's actually kind of copy these over and create them. All right, so I have an addresses table I need to create. So I'm just going to write in my VS Code. Again, I could do this in my terminal since I have pSQL going. but I'm just going to prefer VS Code. It's easier for me to kind of edit and make changes. So in this case, I'm going to do the same thing here. I'm going to drop table. And this will be addresses. And then use create table. And then my data fields. All right, so addresses has 3 fields that we need to give it types to. So we have ID, line 1, and city. So ID, I'm just going to use the same serial primary key. So again, each table should have a primary key because this is what makes your data unique. You could technically, I guess, have a table without a primary key, but then it's not going to be really functional or useful in a relational database. Then we have line 1. So in this case, we make that a var char. Let's make that 255. All right, and city can be a varchar also. So
is having everything lined up required, or more of like just a developer preference?
Sorry, could you repeat the question?
Having everything lined up, like serial, varchar, all that lined up together, is that required, or is that more of just a programmer preference so it's easier to read for you?
Good question. Yeah, it's totally programmer specific. I could just have a space here and we'll work the same. But yeah, I like having things lined up, just slightly easier to read for me. But yeah, totally up to you guys. If you guys don't like spaces, don't have to have them.
Semicolon.
Thank you so much. Pure programming at its finest. But yeah, without the semicolon, I'm not going to be able to run additional statements, and that won't execute. All right, so we have state here. Again, so hopefully you guys are, again, familiar with creating tables. We'll look at maybe some other things we could do. So I have create table.
State and zip code are actually part of the addresses table.
I see. Yes, 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 yes. That would make more sense. Not sure how I dropped that off. All right, zip code, I'm going to actually have that be a varchar instead of an integer, just because I want to keep it as a string. We can make it 5 characters. I know some zip codes can have that additional 4 digits on there. So maybe we just make this 10, be safe. And then we have, all right, so classes is a new one. All right, and then we have so do this quickly.
I think I use character on my zip code and it works for me. I'm not sure if that was wrong or
You use character instead of varchar?
yes.
Yeah, you can use other types. Varchar is usually recommended because, again, that's flexible. Like if you have character 64, I believe that your database is going to allocate 64, I guess, bytes for that data, regardless of how many actual characters in there. So varchar, I think, is a little more efficient in storing the data.
Got it. I just use it for like smaller numbers like the zip code and stuff like that. But okay, yeah, got it.
According to the guy yesterday, if you use varchar, it only uses up, it doesn't add any, it doesn't do any allocation of data. It just will take a memory chunk as big as it needs.
Varchar does use an additional 2 bytes just so that it can expand. So if you know the exact size and know that it will never change, like a grade, you know, is only going to be 2 characters at most, then you could just use char for that. Or if it's a single character, just use char.
Do you have to put the number then?
What do you mean by number? Or the length of it?
Yes.
Yeah, I think you got to specify how many elements are going to be in there.
So I just looked that up actually a few minutes ago. You don't need to put a number in it, but if you don't put a number, it will treat it as a text data type. And then also you're leaving yourself open to users putting in just a really long string of garbage if they wanted to.
All right, this would be char 2, I guess. All right, so I have my tables created here. Hopefully I haven't made a typo, but I usually do. But otherwise, I'm dropping tables and creating them with various fields. So let's see what our basics want. So we create these tables, and then we're just going to feed it in. And then we're probably going to add some relationships here. So again, maybe we haven't talked about foreign keys too much, but these tables actually are related to one another. So we have students that have addresses. So if you notice that we have an address ID here, this address ID is actually referencing the ID here. So eventually we're going to want to create a foreign key relationship. So I'm not doing that right now because I just want to create my tables. But when we actually implement this, we want a foreign key relationship. So address ID references this ID here. Now, something to keep in mind is that you got to have your tables created first before you create foreign keys. So I can't just create my foreign key like here. I can't write it here because my address table does not exist at that point. So I actually get an error if I try to do that. All right, so I have my tables. Let me just make sure this runs. I'm forgetting a parenthesis here, so that was going to cause an error. But I think this should be good to go. So let me drop out of Postgres, clear this, and run my create schema again. And I don't think I got any errors here. It's got some notices, so I think I'm good. Let's actually just make sure. Yep. Or I can refresh this. All right, so I got 4 tables, so addresses, classes, enrollments, and students. All right, so as we have it now, we just have these tables, but the tables don't really interact because, again, we have IDs that kind of reference other tables, but there's nothing enforcing that. So for example, I have a address ID of I could have an address ID of 12, but 12 might not actually exist. So how do we actually enforce this protection? And that's what foreign keys do for us. So you can create foreign keys right in the table, but I usually do it after I create all my tables. So in this case, I'm going to use an alter table statement. And this is going to actually modify my existing tables. So to alter table, I'm going to add constraint. So foreign key is a type of constraint. Other types of constraints you could have are unique keys. So unique keys are similar to primary keys, except that they're you can have multiple unique keys within a table. Primary keys, you can only have one primary key per table. All right, so in this case, I want to have actually not constraint, and do foreign key. And all right, so we need to reference the column. So in this case, address ID is the one I'm going to reference for my students table. So that's going to be here. I got to give my table a name, of course. Address ID, and then you want to tell it what needs to actually reference. All right, so we use references. So this is going to say, hey, this address ID is going to point to some other table. In this case, it's going to reference my other table, which is addresses. And then I need a column name. All right, so if I look at my 2 tables, I'm using address ID, but I'm actually going to have that be a foreign key, and that foreign key is going to point to the actual ID in my addresses table. So ID would be my column here. So I think that looks right. And yeah, semicolon as always. And then let's actually get this wrong. And of course, I have an issue. Alter table, foreign key. What's the issue here?
I think after you reference foreign key, address ID to be wrapped in parentheses.
Gotcha.
No, you have to give the foreign key a unique name. So address ID, I think, needs to be like foreign key underscore address ID.
Foreign key underscore? Like this?
Like typically you would name it like foreign key, so FK underscore address ID.
All right, so this is a great, I think, opportunity. I appreciate you guys' help, but this is where documentation comes into play. So I'm actually kind of fuzzy on my adding foreign key. So I'm actually just gonna search for it. Let's go Postgres, because Postgres has great documentation. Let's go alter table add foreign key. All right, first result seems promising. All right, so we have Postgres foreign key. Let's see what they say. All right, so this is the syntax for it. You need foreign key, and then, yeah, I think we gotta give a name. So I think that's what one of you was saying. Then I give references parent table. Let's see their examples here. So they create two tables, and then let's see an alter table example. Alter table, so you give a table name, add constraint. All right, so that's what I forgot. All right, so I did need to add constraint. My apologies there. And then I'm going to give this a name. So I think string, foreign key, address. All right, I think that should take care of it. Let's just double check. So we need alter table, table name, add constraint, give the constraint a name, foreign key, parentheses. I think that should be correct. So let's try to give that a run and see if we get any errors. All right, no errors. All right, again, thanks for your help. Appreciate it. Again, documentation, great. Postgres has really good documentation, so always helpful to kind of read it whenever you're in the jam. But they give good examples and highly recommend that. All right, so we have this foreign key. So let's actually test this out to see if we can actually break this. So I'm gonna actually, let's see, we have a data file. So we have seed data here. So let's actually look at inserting students. We have, I believe the last parameter is address ID. Look at my schema file. Yeah, so the last value is address ID. All right, so we're gonna add some addresses here. Let's actually try to violate this. So I'm gonna add a bad address ID. So for student Andre Rohan, I'm gonna add a bogus address ID, and let's see what happens if I try to run the C data file. All right, so in the same way that I was able to run my query or schema file, I can do the same thing with my C data. I'm gonna run pSQL, and then my school new database. That's my name of my database. And then use that caret sign to feed in this file, and this is going to be seed data. All right, so again, we're going to create a bunch of addresses, but these addresses are going to have primary keys of 1, 2, 3, and 4. So 99 should actually contain. So when I actually try to do this, let's actually do it piecemeal. So I'm going to maybe, all right, I'm going to do this line last. I'm going to take that out and run my schema or C data. All right, so everything seemed to work correctly. All right, I took out that line that I was going to add later. Let's actually add that line in. So I'm going to actually use pSQL for this. So pSQL school new, go into my database. All right, so now let me bring up my terminal. All right. Oops.
Doesn't work like that.
All right, so I have my line that I copied out. So I'm going to insert a new student. Again, I'm using 99 as my address ID, but if you actually looked at our table, 99 would not exist. So actually, maybe before I do this, there's a quick way to delete all this stuff. All right, so let's actually run a query to check our data. So to run, to view data, we use the select query. In this case, I'm just going to want to view all, so I use a star, and then I pick the table I want to look at the data for. So let's look at students, just to see what our students look like. Forgot my semicolons, as always. All right, so in this case, we only have one student. I'm actually kind of curious as why we only have one student.
So I think you left off the state column from your address table.
Take a look at that.
So the only one that didn't have, like, I think Leopold Town doesn't have some of that information, so that's why I didn't get pulled in there.
Gotcha. Good catch there. I probably, let's see, address, states, yes, and city. So state, thank you so much. All right, so let's quickly add that in there. Bar char, this could be whatever. Make it 32. These are random numbers I'm picking. All right, so I'm gonna have to kind of drop out of this. let's Control D, look at this. Okay, run my schema file again, so I'm gonna lose my data. That's okay, we have a seed file. All right, do that, and then do my seed data. All right, hopefully that inserted, so I had multiple students, right? Yeah, multiple students, let's investigate. Hopefully we got more students in our database now. So again, I could do select star from, and then my table name. So in this case, it's students.
You're
And
not,
level.
you're in the wrong database.
Thank you so much. P-SQL school new is my database. And then so select star from students, semicolon. All right, great. Now we have 4 students in here. Looks like Leopold Town does not have an address ID. Is that on purpose? Leopold, yep, he has a null value for his address ID, so I guess he does not have an address that's stored in our system. But all right, so let's try again that line that I was trying to do. So, all right, insert students down here. Hopefully you guys can read that. Andre Rohan, and his address ID is 99. So let's actually try running this and see what happens. So we had this foreign key that we added. So hopefully this foreign key should protect us from having an invalid address ID. So I'm going to run that. All right, so look, I got an error here saying insert update failed because my foreign key constraint was violated. Again, so this message is actually what I wanted to see because again, we want to enforce the address ID that we have in our students table is actually a valid ID that references an actual address. Otherwise, we're just going to have a bogus address. Again, this can also happen if like we're modifying our address table, then we actually remove addresses from there. Foreign keys will protect you from removing those data records. All right, so again, if we want to add in more foreign keys, we can look at our class table and then enrollments. So enrollments actually has 2 foreign keys that we're going to create, a student ID and a class ID. So student ID will reference the student table, and then class ID should reference the classes table. So again, if we want to do that, we kind of do that really easily. Since we have this, let's just copy and paste. In this case, we have enrollments, and we'll call this student ID from our enrollments table. That's going to reference our students table. And same field, ID. All of them have ID as their primary key. Makes it kind of easy. And we'll copy this. All right, so make sure I'm not going too quickly. Does everyone kind of understand what foreign keys are? Any questions about why we have foreign keys or, you know, when you need to create them?
I wanted to ask about unique. I know that is it like we're only supposed to use it if the foreign key is gonna relate or like refer to multiple things, or how does unique work?
Unique constraints versus foreign keys?
Mm-hmm. But I thought they work together. No?
You can combine them. So we can talk about a use case where combining them might make sense. I'm not sure if there's a good case in our student classes example, but class ID and class. All right. So again, a couple more foreign keys that we're adding on the enrollments table. So we have student ID and class ID. So let's actually run this. Hopefully I have no typos. Looks good enough. Let's clear my screen and let's run this again. I'm going to lose my data, but I'll reseed it later. All right. Classes. Okay, so it looks like everything worked correctly. Again, no errors, got 1 notice. All right, so if you notice up here, I actually got a notice about my cascade. So I had foreign key enrollments for student ID. So in this case, I was trying to drop my student table up here, which is the very first thing I do. However, let's see. Oh, sorry, this is for enrollment. So I have my enrollment table down here. So my enrollment table still exists, and it has a record that could be referencing my student ID from my student table. So that's why I got this notice that Cascade is actually going to drop any record that's referencing my student table. If I did not have that cascade in there, I would likely get an error. So if I did this, remove the cascade, I think this works without data in there. Yep. So I got an error here. Again, the reason this happened is because I'm trying to drop a table that some other table that currently exists relies on for data. Again, that's through the foreign key relationship. So if you don't use cascade, this cascade lets you delete those records. But if cascade's not there, you're not going to be able to drop your table because some other data needs this table to exist for it to have valid records.
Can you explain why you're altering the table afterwards instead of just like including the foreign keys while you're building the tables out?
Sure. So yeah, as you might have seen on the Postgres docs, you can have a foreign key right in your table. So let's actually scroll up to see an example of that.
Well, that's how I did mine too.
Yep. So you can add a constraint like this within your table. So in this case, just add it within your table definition. Same syntax, a constraint, foreign key, references, and then on delete, we left out that part, so we probably should have that. But this is if you, what is it for?
On delete cascade.
Oh, right. Yeah. So we're using cascade, but you could have other options. For example, you can set the values in a different table to null. So in this case, on delete set null means, let's say, we have an enrollments table that references student ID. If we drop our students table, then it'll actually modify that record in the enrollments and set the student ID to null instead of removing that completely. You could also have other options as in, restrict would prevent the table from being deleted. You could also set a default value. So for example, instead of setting it to null, you could set the student ID to like, I don't know, what you would set it to, like 99. I don't know if that makes sense in this use case. But yeah, you have options. So Cascade's not the only option you could use for, foreign keys being removed. But yeah, so the question was, when do you do this versus the way I'm doing it, alter table? Sometimes it's user preference. Again, I like doing it after my tables are created. The reason that you sometimes will have to do this, again, it kind of comes down to how you define your tables. So in this case, I've defined enrollments after I've defined my classes and students. So students happens first, then classes, and then enrollments, which relies on both those tables. But as we have it here currently, students relies on addresses. So the address ID is a foreign key that references this table. However, if this table never was created, then we can't create a foreign key here on a table that doesn't exist. So in this case, the way we have this ordered, we would need to do an alter table statement after the creation. But another way around this is we could simply swap the order of this. I could actually add addresses first. And in this case, I could do it right in here if I wanted to. All right, so again, mostly user preference. I just like having my table definition kind of separated from my foreign keys, but then you can make the argument that it's kind of harder to kind of understand what each field actually is. Like it's not super clear that this is a foreign key right now. So yeah, maybe I could do that in there to make it more clear.
You have to drop all those tables because you previously had them. Could you just run the alter table commands?
Alter table to like add a new field?
Right, yeah.
Yeah, so alter table actually is probably the most complicated of the, table queries. Alter table, again, so just go over stuff you can do. You can add constraints, which are like foreign keys or unique indices. You could add a column. You could drop a column. You could rename a column. You could also alter a column type. So for example, let's say I didn't want my grade to be a varchar 2. I want that to be maybe an integer, or maybe I want that to be like a grade ID that references a grade table. You could also use alter table to modify that. So let's actually do that, just to see an example of it. So in this case, I want to change my grade value to, instead of being a varchar 2, I'm going to make that varchar 4, maybe make that an int, I don't know. Let's just make it an int for this case. So, it would be a GPA value instead of a char. So let's use alter table. Again, this is, so instead of dropping my table and recreating each time, again, if I want to make modifications, this is the common way to do it. I just been doing drop and create just because I have this set up as is. But usually when you have data, as we saw, like you're going to lose your data if you drop your tables and recreate them. So alter table is a way around that, and probably the way you want to do it if you have a lot of data that you can't replace. All right, so in this case, I'm going to do alter column, not alter table. Let's see. So alter table, and then I'm going to do alter column. All right, so in this case, my table is enrollments, and my column, not sure why it doesn't syntax highlight that, grade. All right, and then I want the type. Again, this is all from reading documentation. I don't have this memorized. I have my notes here actually. So type, and then let's see. I want to set type. All right, so I want to set this to int. So I think this should do it. I'll do a set default to 0. All right, so again, this is going to change my type to an int instead of varchar. So if I actually want to see this, let's do SQL. SQL new. Let's go to W4D3. \C, is that what I'm looking for? So \C. Does anyone know how to see details of my table? Oh, \D. D. All right, cool. So in this case, I have a character varying, so varchar 2. But if I actually run this alter table statement that I had created here, assuming I have no typos, which I can never trust myself. All right, cool. So I'm back here.
You need semicolon after the default.
Pardon?
Semicolon after the set default 0.
Thank you so much. Always forget those semicolons. All right, I'm going to run this in my PCQL down here. Hopefully it's not too low for you to see, but basically alter table enrollments. I'm going to alter my column, which is grade. And then I'm going to change this varchar to an integer, hopefully. And then default value for those will be 0. So let's run that. And then of course get an error. Error. Alter column grade type int. Not sure what the issue is here.
Is it, do you need a comma after the int?
I don't think I do. Again, let's go back to docs. Docs will save my life. All right, so Postgres, we wanted to alter table. Table. Again, so we want to change the data type. Again, very convenient. So alter table, we have that. We have column name, set data, type. Okay, so I think it has to be a separate statement. So this is, sorry, I'm doing something incorrectly. Forget the default part. I'm just gonna have this part. Apologies there. All right, so run this. All right, so I got an error, grade cannot be automatically casted. Interesting. All right, let's just make this a little simpler. Sorry for technical difficulties. Extend it to a varchar 4, for example here. Run that. All right, so if I do a \D on my enrollments now, hopefully I should see that reflected. All right, so yeah, this got updated. Again, not quite a really good example, but you know, alter table has a lot of options here. So you modify columns, rename them, drop columns, kind of to modify your table instead of doing the entire process of dropping table and creating table. So this will persist your data versus having you to drop that data and kind of repopulate your data into your database. So just going back a step, I think Jose mentioned unique keys. So let's actually talk about a case for that. So kind of gonna just try to modify this to see how I want it. So let's say my classes has a time slot field, and let's just make that Date time, maybe. But I'm just gonna have this be a varchar or an int. All right, so this is gonna be an int that is gonna be an hour of the day. So it might be 8 for 8 o'clock, 9 for 9 o'clock. Again, maybe that's not the best sign, but kind of want to just have something quick. So I have a time slot, that's gonna be an int. And then let's add a new table. So I'm gonna create a new table for professors. And it's gonna have an ID. Let's say the professors has a name. I don't really care about last name right now. So we'll do varchar 64. And then, all right, so that's my simple professors table. So it just has an ID and name. And then I'm gonna actually have a table for, I guess, when, let's see, if I could have that right here. So I guess each class is going to have one professor that teaches it. It's not going to be a tandem professor crew. So in this case, I could just have a professor ID inside my class table, and that's going to be the professor that teaches this section. So again, this can be a foreign key. So maybe I should move my table up here. Cut that. Put that above. All right, so in this case, I'm going to use the option of adding a constraint right here. So if I want to do that, constraint. It's going to be foreign key for professor ID. Foreign key. All right, so it's going to be foreign key using this column, and that's going to reference the table. In this case, it's going to be professor's table, and the field will be ID that's referencing. All right, so I think that should be what I need. All right, so in this case, we can do it right in the table because again, the professor table exists already. Let me get rid of my terminal. It's kind of eating up my space. All right, so the reason I kind of added these values is because I actually want to add a unique key. So if we actually think about it, we're going to have a professor teaching a particular class in a particular time slot. However, if you have multiple classes going on, the same professor can't be teaching multiple classes in the same time slot. So if you think about our classes table, we're going to have a list of classes that have particular time slots and a professor ID. However, we want to ensure that the time slot combined with the professor ID is unique. All right, so let's just, again, simple example, assume all classes don't overlap. So classes will be from 8 to 9, 9 to 10, 10 to 11 on an hourly schedule. But in this case, we can't have a professor ID like in our 8 o'clock slot and then have a different class that also has an 8 o'clock time slot with the same professor ID. So this is an example where we want to add a unique key. Again, maybe we haven't talked about this before, but it's just another constraint. It's very similar to primary keys. The only difference being primary keys kind of identify your data and you can only have one per table versus unique keys, you could have multiple unique keys within the same table. And that just, again, guarantees that a combination or a particular data. So in this case, we're actually going to have a composite key spanning 2 columns, not just 1. So let's actually try to do this. And I might need to use read up on docs. Constraints. Let's call this UC and time slot professor. All right, so in this case, I want a unique index. So I'm going to have to read up some docs on this. So let's look up unique. All right, so unique constraints. Looks like what I want to do. Maybe. All right, so maybe something like this. All right, give this a try, see what happens. Table add constraints, unique. I might not be able to do this, but I'll give it a try. So in this case, we have 2 columns. So it's going to be time slot and professor ID together. Again, we could have multiple classes with the same professor, as long as they're in different time slots. or we could have multiple classes at the same time slot with different professors, but we can't have the same combination. So we can't have, Professor X teaching 2 classes at 8 o'clock, because that's not going to work well for students. So I think this is the syntax for it, but obviously we can just run this. So I'm actually going to use an alter table since actually I got to recreate these tables anyway, don't I? All right, let's just give this a run. I'll probably run into some errors, but we'll go from there. So let me alt tilde, bring in my terminal. There's my terminal, SQL, SQL new, and create SQL. And yes, so these errors are not usually helpful, but I probably forgot some semicolons or something, so I need a comma here for sure. Don't need a comma here. Again, SQL's kind of finicky that way. Let's try that. So, go to my screen again. All right, hopefully no errors. I got 1 error. Addresses does not exist. Skip me. All right, error line 7. All right, so professor's table looks fine to me. I'm not sure what the error is here. It's always not helpful. If anyone spots my error, I'd be appreciative, but let's see. Oh, I don't need this stuff here. So that was it. Oh, add constraints. All right, let's look at our docs again. So alter table add constraints. Postgres, alter table add constraints. Let's see, constraint name, unique. All right, so maybe I don't need the index part. Hopefully that will fix it. Fingers crossed. All right, for some reason I'm having issues with my constraints. So add constraint FP professor ID. Sorry, I'm having some issues here. Not sure what's wrong with my constraint here.
Do you need to add when you're in the create table?
I thought I did, but it's a good question. Let's see. Foreign. All right, so documentation. All right, so constraints. I see. So we don't need to add. Thank you. Been a while since I've done this. I think that should be what they're asking for. Thank you. Hopefully. All right. No errors. No errors. No errors. Still 1 error. What's going on? All right. So I don't want to waste too much time here. So essentially, the idea is I want to add a unique constraint using 2 columns. So you can do this for multiple columns. Again, 4 columns if it makes sense. But in this case, I have a pair of columns that need to be unique. So again, professor ID is a foreign key, but I also have that professor ID as part of a unique key. In this case, it's a composite key using time slot and professor ID. Apologies for the technical errors. I'm not sure what typos I'm running into, but hopefully you guys get the idea. Again, foreign keys reference a key in some other table. That key can be a primary key in some other table, but it can also be some other unique key in a table. So actually I could have, I can't come up with a good example, but I could have like let's say in my enrollments, I could have a key here that could reference this unique key if I want to. In that case, I would need 2 columns to reference 2 columns for this unique key, but it's actually a way to reuse keys across tables. Again, so I have a foreign key in some other table that would reference this unique constraint that I have implemented here. All right, so that's foreign keys, reference other tables. Unique keys kind of guarantee uniqueness. They're similar to primary keys, except that you can have multiple unique keys in a table. Same thing goes with primary keys. You could actually have a primary key using multiple columns. Usually we just have an ID, so that's good enough. But sometimes you might need a combined field to have a true primary key. All right, so that's I think what we need to for our basics. So take the tester schema, we seeded our file, we get some data from our seed file. And then there's another challenge that I guess hopefully you guys tackle it, but if not, it's a great challenge for practice. The SQL queries, this actually kind of extends what we just did here. So just take a look at that. Hopefully you guys can work on this tonight. If not, basically the data that is provided to us that we populate from our seed data, we're actually going to run some queries. So we're going to try to extract information using SQL. So this will give you good SQL practice. For example, like we have a student named Tiana. We want to know all of her enrollment. So every class she's part of that she has not had a grade for. So again, you kind of want to structure your query like, okay, we're probably going to look up Tiana via the students table using a name, but then we're going to need to extract your student ID and then use that student ID to look into the enrollment table. All right.
Question, Encore.
Yep.
For the assessment, are we gonna have to add foreign keys since that wasn't like part of the curriculum, or we will?
Good
We
question.
will be adding foreign keys.
Okay, thank you.
But yeah, so heads up about the assessment since yeah, it's approaching on Friday. So Tom, correct me if I'm wrong. This is going to be a take home, as in it's going to be you're going to have the weekend to do it.
Yeah, it'll be due Monday at 8:30 a.m.
Yep. So you have the weekend to kind of work it. So it won't be as time restricted. We just want you to get practice with SQL, understand how to query a data set, and you know, be able to use SQL appropriately.
Create a schema. That's the main, that's also really important.
Yeah, so we're going to be basically giving you some requirements. You're going to have to come up with a schema, and then you're going to have to insert data into that database, and then we're going to ask you to run some queries on it to get specific data out of it. So again, this is something that'll be similar to the challenges you're doing. So again, it won't be totally something out of left field. You should be prepared for it if you are able to complete the challenges for this week.
So are we going to be like kind of like just typing out the commands, like creating like a list of commands that we would input, you know, and then you guys, you know, tell us if we're wrong, right?
Yeah, so it'd be similar to this SQL queries challenge. So in this case, you're going to create a file that's going to be like SQL queries or whatever you want to name it, and just have a SQL file that's going to have all your queries in it. So in this case, our C data is doing inserting, our create schema file is doing a bunch of creates, but then you have another file that's going to be doing like select statements for the most part. The select is actually how you query and get data out of your tables. So you just have another SQL file with your select statements to extract you know, particular data. So in this case, you know, we have, I don't know, maybe 15, 20 queries you're going to have to write for this challenge. Again, it could be good practice for just kind of translating a request. Like if I tell you, hey, what's the average grade for all the students in all your classes, or what's the average grade for students in biology 101? So you want to take like a simple human, I guess, query, and then translate that into an SQL query using the knowledge that you know.
Yeah, we'll get into this later. We'll cover the assessment later, but it's not, you can do it essentially in SQL or Python, and we're going to be covering Python tomorrow.
Yep, so Chad's going to be going over connecting Python via Scikab PG, which is just the, I guess, the plugin that lets you run queries on a database using Python. All right, so that was SQL basics. Again, hopefully you guys are getting familiar with SQL. It's probably new to a lot of you guys, but again, just get familiar with it and just understand what you can do with databases. Again, we're going to have you write, you know, queries this week for the most part, but then after this week, I know we're going to kind of get away from queries, and we'll have something called Django, which kind of automatically does the querying for us, which makes our lives as developers easier. Because again, I'm not great with SQL. It definitely takes me a while to kind of write out detailed queries.
Correct me if I'm wrong, we're doing HTML next week too, or no?
Yeah, so we're actually going to start, I think HTML starts this Friday. So again, it's a new topic that's going to start Friday. HTML, CSS, and JavaScript. Again, these are front-end concepts for web development. So we've been mostly focusing on the, I guess, backend. So databases are your backend where all your data is stored. Python is usually used for servers, which is used on the backend. But then we're going to transition to front-end development. So for me, it's more interesting. I like working on the front end, kind of creating a nice presentation layer. And like a nice UI for users. So that's actually something I'm more passionate about for sure.
Yeah, it seems like the front end is more common for a lot of developers.
Yeah, again, you could, we're trying to encourage you guys to be full stack developers, and the full stack means both you have that back end knowledge of like writing servers and databases, and then the front end part, which is designing and creating functionality for the user. But some people just want to focus on being front end developers, which isn't wrong. Like again, if you have an expertise in that and have an interest in that, you can definitely market yourself as a front end developer. But we want to give you experience on both the front end and back end.
And I would refrain from saying that most developers are front end, because
No, I just meant like I said, like it seems like a lot of like developers are more or less front end developers, but like what I mean, like that's their preference. That's from what I've seen. Just the people.
I guess it just comes back down to interest. Like I guess the back end is tends to be more coding heavy. So again, front end developers might just like the design aspect and not like coding as much. So that could be a reason. Again, I don't know what the industry looks like, but
I'm not speaking for everyone. I'm not assuming everyone's preference. I'm just
Gotcha. Yeah. Again, I don't know the industry well enough to know if like front end developers are just easier field to get into, or maybe there's more demand for them. But hard to know there. But
quick question. Sorry, I don't mean to interrupt again. Are we gonna like cover like the difference between like front end, back end, like what they specify in and what they involve?
So it's sort of what I mentioned before. So backend generally refers to like databases and servers. So that's, again, this is something that's solely separated from your end user. So your end user is not going to care about your server and your database, but your end user will care about, the website you create and kind of what features you add. So the front end means it's facing facing the client. So it's in front of them, I guess, is what I kind of interpret it, versus the backend is just far away from the user and more just developer specific.
Yeah. Front end is everything you see on a web browser.
Got it.
All right, cool. Are there any more SQL basics questions, or just kind of general questions about SQL?
What exactly is the difference between a subquery and a query? Like is subquery like where you select and then, like, I'm kind of confused on that. I looked it up in Postgres and I'm just a little bit confused.
I'm actually kind of not sure about that either. So let's quickly Google it.
I think I could be wrong. A subquery is essentially a query that is nested within another query.
Okay, that's what I thought, but I also found it was correlated queries with that, and I was kind of confused because I thought that's what a subquery was, and I saw correlated queries, and then I got kind of confused.
Yeah. So again, queries can get very complicated. So subqueries are just basically, in this case, we have a select statement that calls a where on another query. So you can kind of nest them, one query within each other, and it gets kind of confusing. So this is, again, another reason I kind of struggle with SQL. It kind of just gets kind of messy. Like I can't conceptualize it as easily as like maybe classes and maybe more programming specific. But yeah, hopefully you guys get good practice with this. Again, definitely do the challenges. That's going to prepare you, so don't neglect any of those, especially the SQL ones. There are some tutorials like SQL Zoo. Again, I would highly recommend it because I'm bad with SQL, and that actually challenged me. Like there's, using joins. Again, that's something that Jake and Jack probably went over yesterday a bit. Joins are not simple for me, so definitely getting more practice there can be useful. But yeah, so again, you have your challenges. Again, this is the third day, so hopefully you guys are on the tail end of these challenges. SQL queries will be a great one to go over, but then any additional tutorials that you guys do would be great also. All right, so let's see, what time do I have? It is, all right, 10:56. Let's take a 9-minute break. Let's get into breakout rooms at 11:05, or we can just have you guys watch the lecture. Lecture for today isn't too long, so you guys should be able to finish it by noon. And then obviously ask questions in the November questions channel if you have any questions about the material. But it's about going over schema design. So that's something we might have talked about before, kind of just diagramming your data and kind of creating those connections that we kind of did with our SQL basics, those foreign keys, unique keys, primary keys, and kind of creating those relationships. Also talking about relationships. So we have one-to-one relationships, one-to-many relationships, and then many-to-many relationships, which often require additional tables. So that's kind of the topic for today, but there's not too much material in the lecture for today, so you guys should be able to get through it pretty easily. All right, let's take a break. Let's say 11:07, 10-minute break, and then start watching the lecture when we're in our breakout rooms. All right, guys, see you.